Okay, today we are going to start Unit 3, and Unit 3 has a large focus on hypothesis testing. So this first lesson is just a nice introduction to hypothesis testing, what it is, and the very first step of it. So a hypothesis is a statement or a claim about a characteristic or one or more populations. So you guys know that in science, if you have an idea, if you think something's going to happen, you make a hypothesis. But here is where statistics is different from science. A hypothesis test is a procedure based on sample evidence that is used to test a statement or claim about a characteristic or one or more populations. So we're going to make a hypothesis, and then we're going to do a procedure called a hypothesis test on it. And again, this is based on sample evidence, not population. It's based on sample evidence that's used to test a statement or claim about the characteristics. Now, what's going to seem weird to you is when we start out today, in these first couple lessons, we are not proving the hypothesis true or not. It's going to be a little bit to take into account. So let's look at what a hypothesis test really is. So there are 6 steps in the hypothesis test. This is the whole hypothesis test, what you're going to have to do. Today, we are only focusing on step 1, which is determining the null and alternative hypotheses. That's what we're focusing on. We're not doing anything else today. This, in my opinion, can be the most confusing part, not the most difficult part, but the most confusing part, determining your null and alternative hypotheses. Okay? Now, these are new words to us, so let's talk about null and alternative hypotheses. Okay? First of all, when you're formulating a hypothesis, the null hypothesis is always going to contain an equal sign. Okay? The null hypothesis is always going to contain an equal sign. The alternative hypothesis is going to contain one of these guys, either less than, greater than, or not equal to. So we have different properties about null hypothesis and alternative hypothesis. First of all, a null hypothesis is written like this. It's an H sub 0. When you see that, that is a null hypothesis. Okay? An alternative hypothesis is H sub A or H sub 1. Typically it's H sub A though. So let's talk about some properties of a null hypothesis. First of all, a null hypothesis is a statement about a population parameter. So that could be like mu or sigma squared. This is a statement about a population parameter. We're making an assumption. We're making a hypothesis about something with the population. Okay? Another thing about it is that we always presume it to be true unless we find sample evidence to indicate that it is not. Okay, so it is presumed to be true. We're assuming that yes, it is. Oh goodness. That yes, it is true unless we find sample evidence to indicate that it's not true. Okay? Now, again, just like it said up here, the null hypothesis is always equal. And you're going to understand what that means when we do a couple examples here, but it will always be equal. And then finally, it's not our job to prove the null hypothesis true. And this is what really confuses some people, because in science, when you create a hypothesis, your job is to prove that it's true or prove that it's not. That's not our job when it comes to hypothesis testing in statistics. We know that it's a statement about the population parameter, and it is presumed to be true already. But using our sample evidence, it might indicate that it's not true, but it's not our job to prove that it is. Now, the alternative hypothesis is also about the population parameter. So whatever population parameter we're talking about in the null hypothesis, we're also going to be referring to in the alternative hypothesis. But this is the statement that we are trying to support. If we read the problem, it's going to say, what are we trying to figure out? That's what we're trying to support. That's the alternative hypothesis. Now, when it comes to a hypothesis test, there are only 2 possible outcomes for this test. Okay, the first possible outcome is reject the null hypothesis, meaning that we do not accept it, we reject it, that's not going to work out. Or our second option is fail to reject the null hypothesis. Again, we never prove the null hypothesis is true. We either get enough sample evidence to say, boom, that's not happening. We reject that. Or we don't get enough sample evidence to prove that. Now, our sample evidence isn't going to prove the actual hypothesis true, but it's not going to be enough information to say that it's not true. It's a little bit weird to wrap your head around, but we're going to get pretty good at it this unit. So let's go to the back side and let's try some of these examples. On number 1, it says, it has been claimed that 20% of adults smoke. A recent Gallup survey of 1,016 randomly selected adults showed that 213 of the respondents smoke. So a couple of things that I've picked up about this problem. First of all, it has been claimed that 20%, that's a proportion. That's a proportion. That means that my population parameter, just like we said back here, the statement is always about a population parameter. This population parameter that number 1 is going to be talking about is the population proportion. Now, we want to write our null hypothesis and our alternative hypothesis. So let's start with our null hypothesis. So what we're going to do is we're going to have h sub 0, and we want to figure out what is our null hypothesis. Now, to figure out how to write it, you have to figure out 2 things. First of all, what population am I talking about? And the parameter here is proportion. And second of all, you have to remember that h sub 0 is always going to use the equal sign. Okay? We are always going to use the equal sign on h sub 0. So since we're talking about a proportion, that's going to be a p, and we're always going to use the equal sign, which means equals. And then here, it told me that my proportion was 20%, so that's going to be 0.20 or 0.2. It's up to you. Okay? That's my null hypothesis. That's as easy as it is. There's nothing else to it. Now, the alternative hypothesis is always figured out from the problem. So it says, it has been claimed that 20% of adults smoke. A recent survey of selected adults showed that 213 of the respondents smoke. We have to figure out, what are they trying to figure out? Now I know that's a little bit redundant, but hear me out. We have 3 possibilities: greater than, less than, or not equal to. So if it's greater than, if our alternative hypothesis is going to be greater than, it will specifically say something along the lines of more than that. If it's less than, it's going to say something along the lines of less than that. But when it's not equal to, you're going to see an abundance of different ways. You're going to see different or indifferent or not equal to. You're going to see a bunch of different words. So here, it didn't specifically say greater than or less than, which means we're going to use this symbol for our alternative hypothesis, because either people smoke or they don't smoke. So my alternative hypothesis, h sub a, is going to be the same population parameter, but this time we're going to say don't. The population is not equal to 0.0. So my alternative hypothesis is population is not equal to 0.0. And that's all they want. That's all they want for this problem. We don't have to solve anything. We're just getting practice with the null and alternative hypotheses. On number 2, it says the mean pulse rate in beats per minute of adult females is 76 or lower. Is there sufficient evidence at the 0.02 level to substantiate this claim? So here, the population parameter that they're talking about is mean. Okay, so we're going to start with our null hypothesis. H sub 0 is, and then we look at our population parameter, so mu, and remember the null hypothesis is always equal to, but what did they say that it is? The mean pulse rate in beats per minute of adult females is 76 or lower. Now this confuses some people because they're like, well, Mrs. Getz, 76 or lower would be less than or equal to 76. And you're right. And actually back in the old days when I did learn statistics for the first time, null hypothesis wasn't just limited to an equal sign. In fact, it was exactly whatever they were talking about. So in this case, it would have been mu is less than or equal to 76. But statisticians got it in their brains that they're like, no, that can be too confusing. Instead, we want to focus on just making the null easy and then just focusing on the alternative. So even though this is technically what they're talking about, they always want you to use the equal sign in the null hypothesis. So the number is equal to 76. Okay? Now the alternative hypothesis has to deal with the rest of it. It says, is there sufficient evidence at the 0.02 level? Now, if you'll remember, when it says at the 0.02 level, that's the significance level, which is really our alpha, and we'll need more of that later, but just keep an eye out for that to substantiate this claim. Now, it's a little weird because you're like, wait, substantiate what claim? Well, they said it's 76 or lower. So my alternative hypothesis would be the opposite of that, and the opposite of less than or equal to 76 would be that it's greater than 76. That's my alternative hypothesis. All right, number 3. A manufacturer of chocolate candies would like to know whether its bag filling machine works correctly at the 10-ounce setting. Is there sufficient evidence at the 0.05 level, again, that's our alpha, we'll need that in future lessons, that the bags are underfilled? Assume the population is normally distributed. State the null and alternative hypotheses for this scenario. So we want our null hypothesis and our alternative hypothesis. So let's start with the null hypothesis. First of all, we're talking about a bag filling machine, and they want to know if it works correctly at the 10-ounce setting. So each bag is supposed to have 10 ounces, so that would be an average. So that means our mu is going to equal 10 ounces. Now I have to figure out for the alternative hypothesis what kind of symbol I'm going to use. Now it says, is the sufficient evidence at the 0.05 level that the bags are underfilled? So if you remember back on the front page, one of the properties of my alternative hypothesis is it's the statement we are trying to support. Well, this problem is trying to support that the bags are underfilled, so that would be less than 10.